Good morning, good morning, good morning. It is Tuesday, the 25th of November, and today I am going to be going through the NSAA 2018, going through the Math 1, the Math 2, and the Physics. If you've seen these before, feel free to skip ahead to the actual solve, and because as usual, I'm going to go through the strategy that I use to solve these papers now. So for anyone new, my approach here is um, because the ESAT is so fast, I focus a lot on exam technique. So it's important that the first question I answer be one that I'm very, very confident on. So it'll set the tone of the paper, give me that confidence, give me that momentum. And I'm going to use multiple passes. So the first time through, I'm going to skip every question except those which I know for certain I can answer quickly and accurately. And that'll give me time to go back and answer the rest of them with a little bit extra time saved up. Takes the pressure off the harder questions, gives me that confidence, and kind of makes it more likely that I'm going to be able to answer the questions to the best of my ability, as opposed to the worst case scenario, which is seeing the first question, feeling a bit wobbly on it, spending 3 or 4 minutes actually doing the work, getting an answer which isn't the answer, and then I feel like I've wasted the time, feel like I'm on the back foot, wheels fall off. I will also say at this point, this is the first one I'm doing since the ESAT results have come out, I think, because I think the last one I did was just beforehand, a couple weeks ago. And I don't know about you guys, but I've been finding that like the Math 1 results were for some reason way lower than everything else. And I got some feedback. It might be due to something I mentioned on my UAT live solve, which was, in fact, I wonder if, hold on, let me see if I can get that up for you because I really want to show you that because it's important that you see it. I'll edit this out if I can't find it quickly. But ESAT, UAT, about the ESAT. I'm going to search for the ESAT UAT practice paper and show you that because I just want to make sure this is out there. Yeah, here we go. Specification and practice tests. So if I find this Math 1 practice test, I'm going to start sharing screen so I can show you what I think some of the issue might have been, because this is really important for you to check when you are doing the ESAT. Okay, so I'm going to start sharing screen. I'll have this here so that I know you can see it. Right. So something like this. So some people were clicking that, and what you realize is the interface, the software is not that good. So these bubbles actually stretch the entire way across the screen. So if I click here randomly, just to sort of click you can see the answer keeps on changing. And I know at least one of my students had that happen and needed to check it. But by that point, with his whiteboards, his work was gone. So we had to remember what answer he'd actually put in. And it was just a whole situation. So just make sure your answer is the answer you want it to be before you move off it. And if you're, so sometimes I've done it where I've done like gone through, checked my work and gone, yeah, it is that. And I've double clicked it just to emphasize it. And then if you look, it goes away and then it leaves the question unanswered. So it's not great. So just make sure everything is just like nailed on solid before you move on it, off it even. Okay, but with that said, I'm going to start my run. And as usual, what I'm going to do is, in order to prepare for the worst case scenario, which is that the first questions are very, very difficult, I'm going to take each section from the back on the practice tests, because that's where all the most difficult questions are. So I'm going to go through in the order that they give you the real thing, which is Math 1, then Math 2, then Physics. And yeah, without further ado, let's get started. So sharing screen. In fact, hold on, let me test something. So if I do just that. No, it just shares that. Okay, good to know. Right, so run is going to start. As soon as I get to the bottom of math 1. Apologies. All right, let's see how this goes. I don't have my phone for split times. In fact, I really do need that. So apologies. I'm going to cut this out of the video when it goes live, but I'm just going to pop out real quick. And actually, no, I don't need to do that. It's fine. No, I do need to do that. It's not fine. I will be right back. Terrible perspiration on my part, but my phone is on 6%, which is deeply unhelpful when I need to use it to time for a couple of hours. So I'm going to get my lap times up so I can test to make sure that my splits are what they need to be. And with that said, time to go. Okay, so red sweets, green sweets, identical apart from color, takes a sweet. If red stops, if green is not replaced, takes more. Continues until the red is taken. Takes more green sweets than red sweets. Well, they only take one red sweet, so it means that they take 2 or more. Well, that's going to be 1 minus the probability of taking 0 green minus the probability of taking 1 green. So that's 1 minus, and this is get a red automatically, which is a half. And this is gets 1 green, which is a half, times now 6 out of 11. Okay, so cancels for 2. So that's 22 out of 22 minus 11 out of 22 minus 1 out of 22, which is 10 out of 22, which is 5 out of 11, which is not an answer. But I wonder, I'll come back to that. So let's not waste time. I've done something silly. It'll be easy to fix in the second pass. So the first 5 terms are that, and the term is that. Okay, so when n equals 1, so p plus q equals 2. When n equals 2, 4p plus q equals 17. Subtract those, you get 3p equals 15, so p equals 5, which means that q equals minus 3. So p minus q is 8 over p plus q, which is 2 is 4 is g. Okay. So here, height is 3 centimeters longer than base. It'll be easier if I draw this out, because then I can also zoom in on, so that's S, that's B, that's height, which is 3 centimeters longer than the base of 3. Slip inside is S, area is 14, which is a half times base times height is 14. So b squared plus 3b equals 28. Scrolling down. So that means that b squared plus 3b minus 28 is 0. So b plus 7b minus 4 is 0. So b is minus 7 or 4. Can't be minus 7 because length, so b is 4. So then we go back here. We draw this. That is 2 and 2. And 4 plus 3 is 7. So that is somewhere between 7 and 8 because it's the root of 53. So that's between 7 and 8, which is C. Okay. Okay, circle theorems. So I'll have to explain this more afterwards. What is the angle of QSO? Because I can't draw on this because you won't be able to in the real thing. That angle in there is 15. That angle there is 75 degrees by alternate segment theorem. Hold on, so 15. So by alternate segment theorem, that is 75. 180 minus 75, it gives me these two angles, which are the same. So I divide them by 2 to get in one individual one of that. And if I knock off 15 degrees, I'll get the angle I want, which is going to be minus, well, in fact, I'll call that 30 and put it all over 2. So that's minus 105. So it's 75 over 2, which is C. Okay. 14. Student can select tomato juice or mayonnaise or both or neither. This is looking very Venn diagram-y, but let me see if that's correct. N students select both. 3n plus 1 selected tomato juice, so that means that 2n plus 1 is left for there. 3n minus 1 is only mayo. And there's 7. So this currently totals to 6n. So there's n plus 5 on the outside. Probability of a student chosen at random selecting only mayo. So 3n minus 1 over 7n plus 5 is a third. By finding n, so let's do that now. So 9n minus 3 is 7n plus 5. So 2n is 8 and n is 4. Come on, computer, you can do it. So n equals 4. What is the probability of a student chosen at random selecting only tomatoes? So tomato would be 9 out of 28 out of 33. Is that right? So 28. Okay, something's gone wrong there as well. I'm not going to waste time on it. I'll come back to it. In fact, I'll make a note of coming back for 14, coming back for 18. So let's, again, first pass, I don't worry. I just see what I can mark safe. Then I'll come back for it later. So bearing of, so that if that's P, then 5 on a bearing of 65 puts Q somewhere around there at 5. R is 5 meters from Q, so from Q means I put a north arrow there at Q. On a bearing of 155, that's somewhere there. So that's R, distance of 5. So that's 155 degrees. That's 65. That then becomes 115. So I can get that angle in there. What is the bearing of P from R? Well, this angle here, so complete, so 180 minus that is 25. These are isosceles. Okay, so then these add up to 120 and 150 is 270. So that's actually 90. So these become 45 because it's isosceles and angles at the base are the same. So totaling these up, there's 70, and 360 minus that is 290, which is E. Okay. Uh, 12. So 80% of a number is equal to 2/3 of a second number. So 4/5 of a number is equal to 2/3 of a second number. The whole number ratio of the first number to the second number is x to y. Okay. Well, that means that 12x is equal to 10y. No, not the way to do it. What that means is if I put those to one side, it means that x is equal to 10/12 of y, which means that x is equal to, I should really call them a and b actually. So so that means that a is 5/6 of b. So let's get the a to b ratio. Well, that's 5/6 b to b, which is 5/6 to 1, which is 5 to 6. And therefore x minus y is -1, which is f. Okay. 11. Right, so the original price of 9 was P. The price is increased by 125%. So increasing by 100% is doubling. So in other words, it goes to P plus 5/4 P, which is 9/4 P, and I'm not going to mess that up. Cool. The increased price is then decreased by 40%, which means it goes to 3/5. So 3/5 of 9/4 P is 27 over 20P is what we have now, which is Q. The relationship between P and Q can be expressed as MP equals Q. What's M? It is 27 over 20, which is C. Okay. Okay, we have a regular pentagon. If we have a regular pentagon, we know that all of the angles inside are these totally. So an external angle is 72. So the internal angle is 108. So each one of these angles is 54, which is B. That was fast. I'll explain it more later. In the interest of my run, I'm going to leave that. Okay. Was that right? So 108, 54. Yeah, they're both 54. Oh wait, no, because that was not the center. Okay, let me do this properly. Woo! I'm glad I felt that sort of like, oh, something didn't go right there. It just okay. So that's actually 60. So that's an equilateral triangle. So it means these are the same. And that is 108 minus 60, which is 48. 108 minus 60 is absolutely 48. 180 minus 48 is 132. Divide that by 2 would give you these angles, and that is 66. Don't try and cut corners. Don't make it too simple. You'll end up making it harder. Okay, so 9. Right. Let's keep going. How am I doing on time? Doing okay. I got about another 15 minutes left in the run. So a scale model of a cylindrical pillar is to be made. Full-size pillar has a volume of that. So cylindrical, we know its volume is pi r squared h is 12 pi. Cancel, cancel. The model will be a length ratio of that. Okay, well, this is similar shapes then. So if the length ratio is 1 to 40, then the volume ratio is 1 to 64,000. The full size is 12 pi. So then we need to get mass of the model in grams. We need the volume of the model, and then we need to multiply it by the density. And that's centimeters cubed. So maybe let's get this in centimeters cubed. 10 to the minus 6. 1, 2, 3, 4, 5, 6. No, it's the other way. That's a huge amount of centimeters cubed. Oh no, 12 pi times 10 to the 6. So what did I do to get from there to there? So we have to multiply by 12 pi times 10 to the 6 all over 64 times 10 to the 3. Cancels, 3. 64. 8, 12. So that's 16 and 3. So it is 3,000 pi all over 16 centimeters cubed. Multiply that by the density, which is 4/3. Cancels, cancels for 4. Cancels for 1,000, which makes it 250 pi, which is E. Ooh, that felt dodgy. Okay, let's see how that went later. I'm not really employing much skipping as well, which is unusual for me. Right, so those are the straight lines. Enclose a region K. Let's draw it out. So x equals 0, y equals 3x minus 23. And this other one is 2y is minus 5x plus 20. So y is minus 5 over 2x plus 10. So 10 with a negative gradient like that. I've drawn that. That won't be where that is. Let's find out where that point of intersection is, though. So if y is equal to that, then we get 5x plus twice of y equals 20, which means that 5x plus 6x minus 46 equals 20. 11x equals 66. X equals 6. That's all we need to know, because here we know that this up here is going to be 10, and this down here is going to be minus 23, which means that this distance here is 33, and that distance there to the x there is 6. So the area of that triangle is going to be half of the base of 33 times the height of 6. Cancel that down for 3. So 3 times 33 is 99, and the answer is C. Okay. Right, so 7. In fact, I can give myself a bit more working space. 7. The mean of n numbers is p. That means the total is equal to np for those. The mean of 2 of these numbers is q. So the sum of the n numbers, and then the sum of the 2 numbers is 2q. The mean of the remaining numbers, well, the sum then of the n minus 2 remaining elements is going to be np minus 2q, and the average is going to be that over n minus 2, which is 10. So we need to make n the subject of this formula. So np minus 2q is 10n minus 20. Get it. So np minus 10n is equal to 2q minus 20. So n is equal to 2q minus 20 all over p minus 10. So 2 into q minus 10 over p minus 10, and the answer is A. Okay. So another similar shapes for areas and volumes now. I'll go back out. Cool. So this is question 6. Mathematically similar, ratio of the heights. So this is length, area, volume. So the length is 4 to 5. So the volume is 64 to 125. What is the volume of a large cup? Well, that is 320. So that scale factor is, I think it's 5. It is 5. So multiply that by 5, you get to 625, and that makes the answer E. Cool. So here, the expected number of bottles of water sold during a day is directly proportional to the square of the average temperature outside. So what that means is the number of B1 over T1 squared equals B2 over T2 squared. So 64 over 16 squared equals 256 over T2 squared. Oh, wait, no. Read the information, Patrick. Right. Which is 31 more than the expected number for that day. So the actual expected number for that day would not have been 256. It would have been 225. Sir, do you do ENGAA and ESAT questions? Yes, I do. The thing about that, though, is the ENGAA and the ESAT, the NSAA basically draw from exactly the same questions, which is why they merged them into the ESAT. So if you actually look at the ENGAA for 2018, you'll realize the questions are practically identical. So yeah, I actually encourage sort of cross-pollination. You can do either or. There'll be a tiny overlap, but on the whole, they'll be basically the same. So what we can do is we can rearrange this for t squared. So t squared is 225 over 64 times 16 squared. which means that t is going to be 15 over 8 times 16. Cancel that down for 2, so t is equal to 30, which is C. And in fact, I'll show you that at the end, that they're basically the same. So for 4, so we have a rectangle drawn inside a circle, vertices on the circumference. The ratio of the length of PQ to QR is 2 to 1. So if I kind of draw this out, what that means is if that is x, then that is 2x. The area of the rectangle, which is 2x squared, is equal to 96, which means that x squared is equal to 48, which I don't like, but whatever, it is what it is. So that's 48. So x is equal to 2 root 12. No, so that's 3 times 16. So it's 4 root 3. What is the radius? Well, okay, so that is twice the radius. So twice the radius squared is x squared plus 4x squared. What is the radius of the circle? Well, it's 5x squared, so 4r squared is 5x squared. So 5 over 4x squared square rooted. X squared is 48, so it's the root of 5/4 of 48. Cancel that down for 12, so it's root 60. Which is, so it's root 60, which is 4 times 50, so 2 root 15, which is D. Okay, running out of time a little bit, so I should pick up the pace. So I'm going to get back to those 2 questions I skipped. So 3, the line joining the points with those coordinates. Well, let's get what that is. It's parallel to the line, so we want the gradient. The gradient is, yeah, so let's do this. So 2p minus that. So in fact, let me just cut straight there. So the difference, the gradient is the change in y over change in x. So 2p minus that leaves me with p plus 1 all over this minus p, which is 1 minus 2p. That is the gradient of this line. And it's, let's get the gradient of this other line. So 3y is minus 2x minus 1. So y is minus 2/3 x minus 1/3. So the gradient that it's parallel to is minus 2/3. And so rearranging this, we get 3p plus 3 is equal to minus 2 plus 4p. Moving, so 5 is equal to p, which is h. So for 2, cuboid has length of that volume, which is 2 root 2x cubed, is numerically equal to twice the total surface area. Now, the surface area is going to be 2 times, well, if I can, it's that times that twice. It's that times that twice, and it's that times that twice. So 2 times root 2x squared plus 2 times 2x squared, which is 4x squared, plus 2 times 2 root 2x squared, which is 4 root 2x squared. I'll explain that in better detail when I have time. So that's 2 into 6 root 2x squared plus 4x squared, which is 12 root 2x squared plus 8x squared. What is the value of x? Well, dividing through by x, 12 root 2 plus 8. So x is equal to 12 root 2 plus 8 all over 2 root 2. Multiply top and bottom by root 2. We're going to get 24 plus 8 root 2 all over 4, which is 6 plus 2 root 2, which is B. Okay, I've got 3 minutes left. Question 1. Group of divers consisting of that was asked if they passed their driving test at the first attempt. 167 of the group say they passed at the first attempt. Of the women, 143. Double again. Maybe, but again, this is me just doing a dry run, so I may have got that wrong, and it's me demonstrating, like, good attempt. So in 3 minutes, we're going to find out. So a group of drivers consisting was after they passed at the first attempt, although 167 say they passed. Okay, this looks like two-way table. So men, women, pass, fail. 200 women, 300 men. 167 passed out of the 500. So 333 failed. Of the women, 143 failed. How many of the men passed? So that means that 57 make up that, which means that 110 makes up that, which means that 190 makes up that. So 110 passed first attempt. E. Cool. I got to go back to 18 and 14. I don't know why I got this wrong. So no. Let me go. No, again, no. Okay, so let me go back to 14. I've only got a minute left, so let me make some sensible guesses. Select only mayonnaise, use and totals, both. So that over that equals a third. I think I solved it. So n was equal to 4. By finding n, what's the probability of students selecting only tomato sauce? So it should be 9 out of the total of 33. Oh my god, that's just 3 over 11, which is A. Okay, okay. Good. Then 18, and I've got 30 seconds left. 18. Okay, so probably is a half of doing it. So 10. Let's just say B, because it looks closest to what I've got. 6 seconds done. Okay, time to stop. Right. Woo! Okay, that was the first run. Now I'm going to mark it up. Before I do that, though, right, let me see what that comment was. Did you not have to double again because two sides have the same surface area? I think I did double again. If I go back to that, that's why I had the big 2 out the front. So that the big 2 out the front here was me sort of doubling again, as it were. So I think we're on the same page there. But again, because I had to sort of speed run it, now I'm going to go back through and explain it a bit better. But I'm actually going to start by showing a comparison with the ESAT, the ENGAA, to show that they are functionally the same thing and why I kind of like I'm only doing the NSAA for now. So if I find, hold on, let me do this out here. So let me get the ENGAA past papers. So I got answers down for everything there, but timing was a bit rough. I think part of that is the fact that I'm doing it kind of first thing in the morning for me. So ENGAA 2018. I'll get that downloaded just so it looks good on the screen. And then opening that up, let's compare them. So if we have a look at this, we'll see. If we look at the math side, you'll see, look at this, exactly the same question. Now with the ENGAA, they mix in, they alternate math, physics. So imagine these physics questions are going to be the ones we're about to see in the physics section. But look, this is exactly the same. This is exactly the same. This is exactly the same. This is the same. This is the same. Like all the questions are identical, but it means you get more questions by doing the NSAA. Because you'll realize that, so these are the same up until this point. but then the paper stops a little bit earlier than the NSAA paper stops. So if you do the NSAA papers, you get 4 extra questions, so a little more bang for your buck. So these are the same, and then I think it stops. Yeah. So for the NSAA, it takes us up to basically question. Well, it took us up to here, but it just didn't have all the questions in it. So that's why it's worth doing the NSAA paper for these runs. You just get a little bit more content for it. So that explains that. Now let's go through. I want to take let's mark it up just to make sure I'm actually doing everything correctly and look at my split times. So looking at the split times, everything looks largely okay. I'll mark up the ones that weren't great, but first let's get it marked. So going from the top, 18 is the one I'm least confident on because it was a bit of a guess. I did something wrong. But 18, the answer was B. Okay, I got that right, but let's kind of rerun that to see how it should have gone. So what happened here? Bag contains that. Sweets are identical apart from the color. So if the sweet is red, the child stops it. So, okay, so the more green than red. We're going to do 1 minus not more green than red. So if the first one is red, the probability is just a half, because that's 6 over 12. Or you can take a green, which is 6 out of 12, and then you take a red, which is 6 out of 11. That cancels down for 2. That's 3. Oh, I forgot to make that a 3. That's what I did. That was what I did. So I canceled that. Okay, if I zoom in a little bit, you can see I canceled that one down to a 2, but I said that was a 12th. No, that should have been a half times 6 out of 11. Okay, that was the error. So at this point, it should have been, so 1 minus a half minus 3 out of 11ths. So I should have made that 22 out of 22 minus 11 out of 22 minus 6 out of 22, which is 5 out of 22, which is B. So that's what that should have been. So I just made a small execution error there. It happens, but you'll notice, look at the way I handled that, where I kind of went, all right, based on how much time I have left, can't rerun it. Based on the form, it looks like I've probably done something silly. That's the one that looks the closest. So I didn't freak out. I just made an educated guess that seemed the closest to what I was doing. Okay, so then 17, G, 16C, 15C, 14A, 13E, 12F, 11C, 10D, 9E, 8C, 7A, 6E, 5C, 4D, 3H, 2B, 1E. Smashed it. Okay, so now, where did I go? All right, so now I'm going to go through, I'm going to give some commentary on the questions, see if I need to explain anything in a bit more detail, because a lot of that was speedrun, and then I'll move on to the math 2. So taking it from 18, which was my first, I've already commentated on that now. Split time for the first run, 113, which was fine. I made sure not to waste too much time on that, by the way. You saw how much I ran out of time. So the second I got it wrong, I went, no, skip, not wasting time on it. Time is better spent on questions I'm definitely getting right. Then 17, I think I explained that okay. You just substitute for ends as required, and that was 43 seconds, which was fine. 16, again, I think that was fairly well explained for 126. Okay, this one, let's go through in a bit more detail. Got this one done in 104, which was good. Let me be a bit clearer in my commentary. So here, this is alternate segment theorem. Angle width between a chord and a tangent on one side equals the angle the chord makes with the circumference on the other side. That's 75. These are the same, so isosceles triangle. That's why you do 180 minus the 75 divided by 2. And we know tangent radius is 90 degrees, so that makes 15 up for the rest of that angle, which is why it was 180 minus 75 over 2 minus 15, and then you simplify. So not too bad. This one, again, I just didn't simplify 9/33 because reasons, I don't know. But that's the kind of thing that can happen to you in the stress of the run. Rather than redo the whole question, came back, spotted it with fresh eyes, was totally fine. Bearings. So this all, whenever you have a bearings question, it relies on the fact that co-interior angles between parallel lines sum up to 180. So as soon as that's 65, that becomes 115. If that's 155, that becomes 25, so that they all add to 180. You can then get the angles around here, which is 90. And because these are both 5, it's isosceles, that's 45. Add them together, 360 minus. Boom. 12 was self-explanatory. As was 11. This, I think, well, let me just go through that in a bit more detail, which is to say, for a regular, I always go by the external angle. So the fact that it's a pentagon means the external angle is 360 over 5, which is 72 degrees, which means the internal angle is 108. That was 60 minus the 108 gives you 48. And then the rest is self-explanatory. Will you do another interview prep video? Yes, I do interview prep every Thursday. So there'll definitely be another one of those. So we got a couple of Thursdays left before the interview, I think. So scale model, that took a lot of time and effort, but I did manage to get there. I think that was pretty self-explanatory. If it was tricky though, this one they love a good triangle in coordinate geometry, where you, instead of working out, because a lot of times as well they're like perpendicular, so they think, oh, I have to work out that length and then do half base times sine on that. No, do it based on the x and y. Much faster. 7 was good if you lay it out cleanly. So the sum of the n, the sum of the 2, and then the sum of the n minus 2, and just lay everything out very methodically, and then it all just works out. This one, again, they liked every paper, they seem to lean on a particular skill. So I think the run in the ESAT run in October, the math one leaned a lot on probability. This one seems to lean a lot on these similar shapes. So knowing that if the length ratio is 4 to 5, you cube that up for the volume ratio. Scale up as required. Okay, so this one, a lot of people would be tempted to work out the constant of proportionality there. I think that's wasted effort, so I prefer to use something more similar to like Boyle's law, because then the constant is b over t squared, which means that b1 over t1 squared equals b2 over t2 squared. For me personally, it gets you there a lot faster. So I didn't need to waste any seconds calculating k. So this, I think, was self-explanatory, if a little annoying. I probably didn't need to square root this to work out the x, because that x squared I just carried across into here. I think that's fine, though. Yeah, that was fine. This, I probably didn't explain it super well, so let me just draw it out to make clear what I was actually thinking in my head. So you've got your sort of cuboid situation. If that was your 2x, and that was your x, and that was your root 2x, then what, so this, the 2 root 2x squared, okay, so the first, okay, so what I did was, this face would be root 2x squared. This face is root 2x squared. And I knew I was going to have 2 of them, which is why I doubled that up to 2 root 2x squared. Same thing here. How bad do you reckon an average of 5.5 is? 5.5 is not bad, honestly. Like, a lot of my cohort have been getting around the same. And I'm actually really curious if you found the same, but they were getting like sort of similar to that, sort of 5.5s in math 2 and physics, and then like 5.0 or 4.9 in Math 1. So I don't know what happened there, but Math 1 seemed to fall apart for a lot of my cohort. I don't reckon that average is that bad, but it does mean especially if you've already got an interview for an interview. If you've already got an invitation for interview, it means they've let you in the door for at least that. Put in a good interview, you can easily get in. There are people in Cambridge right now with an average of like 4 point something. 5.1 in math, 5.2 in math 1, math 2, but 6.1 in physics. Yeah, I think that's fine. I think that's fine. They might sort of be checking on your math skills. So your graph sketching in particular might be coming up. And if you know that your math didn't go so well in the ESAT, maybe make sure you're just like not making those little execution errors in your math in the interview situation. Although I will also say I'm not sure how much the interviewers will specifically be looking at your ESAT scores. They may or may not. Like, you never really know. So sometimes they treat the interviewers completely independent. Either way, go in and absolutely smash the interview, and at least you can walk away with no regrets. So carrying on here. So that's where our root 2x squared came from. I doubled that up because it was happening on two sides, and I did the same thing here. So 2x squared on there, and on the back brings that up to 4x squared, 2 root 2x squared, and same on the other side, you can see that. So this thing in here is my total surface area, which I double up to fill out the equation. Yeah, I mean, that's the thing. So if you think the math, people often find that. So if you think the math physics went badly and yet that was your best score, chances are it's because everyone found it badly and it's just marked on a curve. So it just means that in a paper, that if the math was easier, then everyone did well, and then you did comparatively worse. Cool. And then question 1 was self-explanatory. Right. I'm going to dip in now to do math 2, which is going to suck. So I'm going to be a little less responsive to comments because it's just going to be brutal. It's going to be a 13-minute slog. And last time I completely bombed the timing. So I'm going to be an absolute speed demon through this just to make sure I get through it. Okay, so this is the physics. So it's going to be every other question, 13 minutes and 20 seconds on the clock. Starting with 89. And let's go. Right. The volume is that. The surface area is maximum volume. Okay, I know I can do this, but it's going to take time. That's an optimization problem. Okay, so given those integrals, what's the value of m? I can do integrals. So that means that x to the m, so that's 87, x to the m plus 1 over m plus 1. So between 2 and 0, so that's going to be 2 to the n plus 1 over that equals 16 root 2 over 7. And 2 to the m plus 2 over m plus 2 is 32 root 2 over 9. I'm going to do this divided by this. This divided by that on the top will just give me 2. M plus 1 over m plus 2 from dividing that by that equals that by that, gives me 2 times 7 over 9. What's the value of m? So 2m plus 2 over m plus 2 is 14 over 9. So that means that 18m plus 18 equals 14m plus 28. So 4m equals 10. So m is equal to 5 over 2. Good. Which is equal to E. Lock it in. Next. Coefficient of x cubed. Clever, clever, clever. Right. Not going to fool me. Not today. Because if you'll notice, that is 1 minus 2x, 1 plus 2x, all to the 5, which is 1 minus 4x squared, all to the 5. You can only get even powers of x there. X cubed is going to be 0, which is d. Not today. 83. That's a circle equation. Length of the tangent from C to the point P is that. Okay, let's draw this out. So it's a circle. Length of a tangent to a point is 5 root 3. Radius, right angles. Radius is root 5. What is the shortest distance from P to the circle? Well, that will be root 5. So it's this distance of x. And we know that that squared of 5 and that squared of 75 equals that squared. So 80. And if I root 80, 80 is 16 times 5. So 4 root 5 equals x plus root 5. So x is equal to 3 root 5, which is c. Boom. Okay. Evaluate this. Okay, log laws. So this is going to be log 2 of 5 over 4 times 6 over 5 times 7 over 6. Everything's canceling down. Times 63 over 62 times 64 over 63. Everything's canceling down, cancels down, cancels down. So it's going to be log 2 of 64 over 4 is 16, which is 4, which is c. Okay. Uh, 79. Arithmetic progression. So the 13th term, which is a plus 12d, is 6a, which immediately gives us that 12d is equal to 5a, which is just interesting. Let's see what I want to do with that later. So the 11th term, which is a plus 10d, is 1 less than twice the 5th term. Okay. What is the third term? So we are looking for a plus 2d. So I might need to form, 2d might be more convenient to form. So 2a plus 8d minus 1. So 2d, which I said would be convenient, equals a minus 1. So we're looking for, in other words, 2a minus 1. And from here, so 6a minus 6 is equal to 5a. So a is equal to 6. And then this is equal to 11, which is e. Okay. I'll get to that comment when I'm done with the run. Because again, I'm trying to lock in, stay super, super focused. Mentality is so important in math too. The line that where k is a constant is tangent to the curve. Okay, so we're going to differentiate. Differentiate this, and we're going to get 6x minus 2. We know the gradient of this line is 1. Let's find out where that is. So 6x is equal to 3, which means that x is equal to a half. We know that the y-coordinate at that point is going to be 3/4 minus 1 plus 1. So it goes through the point a half, 3/4, which means that k is equal to a quarter, which is c. Boom, I'll explain later. Here, how many solutions does that? Okay, do not divide through by sine theta. You would be eliminating a solution. So 2 sine cubed minus sine equals 0. So sine 2 sine squared minus 1 equals 0. So either sine equals 0 or sine equals plus or minus 1 over root 2. Let's draw this out and be careful about the interval here. So sine, I'll just draw a full amount. Now minus pi over 2 is there, pi is there. So there are, and it can be equal to, so there's 2 values for that. And then 2 values for that, and then 1 value for that. So there's 5 solutions, which is D. Okay. This feels like a good run so far. So 73. Curve is that equation, line is that equation, area enclosed by the thing. Right. So 9 minus x squared goes something like this. Y equals 5 is that. I'm going to use the A-level formula, which is the integral from, oh, actually, let's work out where they're equal. So that is going to be, they're going to be equal at when 9 minus x squared is equal to 5. So x squared is equal to 4. So that's going to be plus or minus 2. I know this thing has symmetry, so I'm actually going to say that the area is going to be twice the integral from 0 to 2 of the top line minus the bottom line, which is, so it's going to be 4 minus x squared. So it's going to be twice 4x minus a third x cubed from 0 to 2. So that means it's going to be twice into 8 minus 8 over 3. So that's going to be twice into 16 over 3, which is 32 over 3, which is A. Okay. That is that. So let me just do that final question. I'm smashing this in terms of time, mainly because I found some good workarounds. 89. So the dimensions of that volume is that. So 576 is equal to 2x squared y. Okay, so the surface area, which is, as we said before, it's going to be 2 times 2x squared, so 4x squared. 2 times xy, so 2xy, and 2 lots of 2xy, which is 4xy. So the surface area is 4x squared and 6xy. From here, I can say that y is equal to 576 over 2x squared. So it's 4x squared plus 6x into 576 over 2x squared. Not simplifying because things might cancel. 3x. So it's so the surface area is 4x squared plus 3 times 576 to x to the minus 1. I'm going to differentiate that and get 8x minus 3 times 576 over x squared, and that will be equal to 0. Multiplied by x cubed, I'm going to get 8x cubed minus what equals 3 times 576. Nope. So x cubed is equal to 3 times 576 over 8. Man, you're actually going to make me do this, aren't you? God damn it. Oh, maybe not, maybe not, maybe not. So that is the value of x. What is that area? So what is the area of the face that has the largest area? So you're going to have to find x. Oh my God. All right, I can see. Glad I left this to the end. And I'm glad I have time. So, okay, let's cancel this down. So that's going to go, let's cancel the 4 first. I'm just going to assume, so 54, 36. No, so let's do 4. So that's going to leave me 2 on the bottom. 1, 4, 4. So it does cancel down further to make that 72. And 3 times 72 is 216. Which means that x, I believe, is just 6. That's delightful. So it's 6 and 12. And y is 576 all over 576 all over 2 times 36. Well, let's cancel down. Well, there's definitely a 6 in there. 96, 16, 8. So the largest area is 96, which is C. Boom. And I think I'm done way early, which is great. So let me check and see if I did anything silly. So that's done and I'm satisfied. That I think I'm satisfied. Let me just 2 and So that's going to stay on the bottom. That's going to go on the top equals that. So that divide that is 2. That's going to stay on the bottom. That's going to go on the top. And then I'm satisfied. Cool. I have time to check. So I'm checking just, I loved my solution there. I liked that. I liked that. I liked that. I liked that. There may have been execution errors. I did enjoy that. I did like that. All right, I'm actually going to call it there. I'm going to call it there. Got about a minute to spare. I liked that run. That was much better than last week. Last time I did one of these a fortnight ago. Let's mark it up though and see how it went. The split times. Yeah, and the reason why I know this went well, by the way, is every single one of my split times is less than the 1 minute 30, apart from that optimization problem, which took me 4.5 minutes. So if I had done that question first, 4.5 minutes burned, I would have been panicking about the rest of it. So that's the purpose of multiple pass, to make sure that all of your quick ones are done early, so you feel like you have that kind of cushion to spend. Right, let's get into it. Nope. Come on, tech. So let's find 87, which was E, 85, which was D, 83 was C, 81 was C, 79 was E, 77 was C, 75 was D, 73 was A, and 89 was C. Boom! Full marks on that. This could be the run. I'm not sure I've ever had a run where I've jinxed it now. God damn it. No, bad. All right. Some of those I did very quickly though. So let me explain how my brain worked. So 87 wasn't too bad. It was just the being very diligent with the fractions. So taking that second one and dividing by the first one, I knew the top of that. So that is just 2 times 2 to the n plus 1. So that divided by that would leave me with a single 2. And when I'm dividing this fraction, this would be key change flips. So this m over n plus 2 stays on the bottom. This m plus 1 goes on the top, which is how I formed that. Same idea here. This this divided by this gives me the 2. And then same thing here. The 7 flips onto the top and the 9 stays on the bottom. And from there, it's just a case of rearranging. I loved this. So if you can spot any trick, but actually, no, sorry. Let me read this comment. By the way, thank you. Your channel is genuinely gem. Oh, thank you. Discovered it after the ESAT. Apologies for that. I only really started doing it like a week, like a couple of weeks before the ESAT, mainly because I was just getting all my tech up and running. I discovered it after that, but I find your interview tutorials excellent. I would take private lessons if I could afford them. Well, that's part of why I'm doing this as well, is to try and make sure that people have access to it, even if you can't afford it, to kind of democratize it, right? The way to make the most of this channel, if you can't afford private tuition, I'm giving you everything that I would be giving you in session. It's just going to be up to you to link it up inside and see exactly how everything's working inside of me and try and replicate that as much as possible. So you can still try and emulate the process I'm going through. And I will say, I managed to make it through without any tutoring at all. So don't feel like you need tutoring in order to get by. Right? So you can absolutely do everything that I've done. It's just learning more through osmosis. So so spotting this difference of 2 squares, turning it into 1 minus 4x squared to the power of 5. So that means that every single power of x has to be, so it's 1 plus and then every power, it's going to be x squared squared or x squared cubed. Every power of x I get in this expansion is going to be even. So there is no x cubed in this expansion. A lot of people waste so much time there. Here, I think that was pretty self-explanatory. Here, I think that was pretty self-explanatory. This, also self-explanatory. 77. We know the gradient is 1. So you differentiate set to 1, find the x. So we know the coordinates of the point that this goes through. So then it's just basically plugging it back in and saying 3/4 is equal to a half plus k, so k is equal to a quarter. Not too bad. This would have been bad if I wasn't more diligent about drawing this graph. So graphs are a huge help. And never, ever, ever, ever dividing through by sign because you will lose solutions. And here, okay. So this one I did quickly using skills that I know. Here are two skills that I knew for this. And we could have done this different ways. And this actually could be helpful for interview, by the way. So here, if an integral is symmetrical about the y-axis, you can exploit that symmetry. So if the function is even, like this is, we know, so for instance, if that is between minus a and a, I know that the integral from minus a to a will be equal to twice the integral from 0 to a, because this area is going to be equal to this area. So I exploited that so I wouldn't have to worry about substituting in -2 and making a sign error. I knew that substituting in 0 was going to make that a lot easier. So that's why I exploited that symmetry. I also knew that finding the area between two functions, so if that is function f1 and that is function f2, then the area would be equal to the integral of f1 minus f2, which is why I integrated 4 minus x squared. Because the 9x squared, it was 9 minus x squared, and I took off a 5 from that. So by putting those two ideas together, that's how I made that a very simple integral. And from there, it was just a case of substituting in, making sure I make no execution errors. And that was it for that run. Now it's time for physics. Now let's see how badly I jinxed it. Okay, so I remember last time I made some execution errors in the physics, so I want to try not to do that today. Okay, let me get through the physics. No peeking, no spoily. Can you divide by... You can divide by sign. You just have to keep in mind that one solution is when sine x equals 0. Yes, but it's better for him not to. Because if you factorize it out, then it is right there for you. So if I look back at the work, and the problem with the solution with sine x equals 0 is if you're dividing it through, then you would be dividing by 0, which isn't like a great look. I would just advise always factorize out, because then it's clear, because the two factors multiply to give you 0, it's like in the same way that you factorize quadratics, either the sine is equal to 0 or this thing is equal to 0. And therefore, it just means you have to remember less in your head, and it's all more on paper. Frees up the brain to think about other things. And it will impress more at an interview. It just looks more elegant and rigorous. So is this, yeah, this is the start of the physics. So 26 minutes and 40 seconds on the clock. I'll keep an eye on the chat, but I imagine I'll be a little less responsive, but I'll try and respond if I can. Ready, and go. So 3 detectors are separated by a large distance. Each of the detectors records a wave. The epicenter is very close to the Earth. The wave travels out from the epicenter at a speed. Okay, so like we have, so let's say this is the earthquake. So it's the same distance to X and Y, but Z detects it 1 minute later. So Z is further away, which must be correct. The epicenter is at the midpoint. No, the epicenter could lie beneath and just be equidistant to X and Y. Z is equidistant from X and Y. No, it could be closer to Y than X, as in the case here. Z is no more than that much away from X and from Y. No, because it can be much further away from X, as I've drawn it here. None of them have to be correct. That's A. Here, filament lamp connected in series with a power supply of constant voltage. The graph is that the resistance is 4, the current is 2. Okay, let me draw this out. So the filament lamp and a variable resistor, so 35 Power supply of constant voltage. Right. Power supply of constant voltage, lamp, variable resistor, that. When that is 4, the current here is 2. When the current is 2, the voltage is 6. And which resistance is 3 ohms because V equals IR. So when that's 4, what is the power when the resistance of the variable is 0? When that's 0, then it was, hold on, the total of resistance was 7 times 2. So that voltage is 14. So that becomes 14. No, hang on a minute. When that's 4, the current in the lamp is 2 amps, which means the voltage of the lamp is 6. No. Okay. So because the resistance changes. So that's 6 volts. So that is 14. So when the voltage is 14, the current is 3, and power is I squared. Well, P equals IV. P equals IV. So 3 times 14 is 42 watts, which is E. That took too long. Whatever. I got this. Here. 3 identical resistors. The total power supplied by the battery is 18. What's the power in X? Well, I know that these are identical, so half the current is going to go into there and there. So that's I over 2. This has full current. P is proportional to I squared. So this has double the current, so it will have 4 times the power. So that'll have 4P, that'll have P, that'll have P. So the total is 6P, which is 18 watts. So with power, there is 3 watts, which is C. I'll explain better later. For now, I want to put together the run. 33. Neutron is absorbed by that. Undergoes fission to produce that, and some neutrons. That is radioactive and emits a beta. How many neutrons are emitted in the fission reaction, and how many protons are in there? Okay. So a neutron, so a 1, 0 neutron is absorbed by a 2, 3, 5, 92 uranium, and it goes to an 88, 35 bromine, and a 1, 4, 5, and an I don't care lanthanum, if that's what that is. Numbers on the top, 2, 3, 6 goes to 92, 3, 3. So there must be 3 neutrons. And then a 1, 4, 5 emits a beta. And how many protons on there? Oh, I do have to care. So that minus that is 57. And then it emits a beta, so it gains 1 to make it 58. So 3 and 58 is H. Lock it in. Okay. 33. Stay on it. No mistakes. If I can avoid it. So 33. Generates water waves of a fixed frequency. As they cross the boundary into shallower water, their frequency does not change. Speed is reduced. New way of thinking is that. Deep. Shallow. VF lambda, VF lambda. Lambda is 1.5. What is the speed in the shallow water? So let's call that V. When it goes into shallow water, the speed is reduced by that. So this was V plus 18. The new way to think is 1.2. V equals F lambda. V2 is F lambda 2. Let's divide the equations through. So V1 over V2 equals lambda 1 over lambda 2, and that ratio is 1.5 all over 1.2, which is 15 over 12, which is 5 over 4. So it means that V plus 18 all over V equals 5 over 4, and I can solve that for V. So 4V plus 72 equals 5V. So 72 equals V, which is E. Okay. Skydiver weighed 1,000 newtons falls vertically. Distance time graph, we can work out the speed from that. Air resistance is given, so I got the speed. Okay, so what is the final speed? Man, this is going to be a pain. I'm going to come back to this. So 31, got to come back to. So for 30, as you see later on a balance. So for 30, places a measuring cylinder on a balance, pours a volume V of water into the measuring cylinder and finds the mass. So the cylinder and the water together is 280. Dries it before putting it back in. Pours in the same volume of olive oil. So the measuring cylinder plus rho water V is 290. The measuring cylinder plus rho oil V is 270. So subtract, the densities are that. So let's subtract them. So the density of water minus the density of oil times V is equal to 20 grams. So 0.1 V equals 20, so V equals 200. So from here, 200 grams of that is water, and the mass must be 90, which is C. Okay. 29. Transverse wave with an amplitude. For frequency that travels along a rope at speed of that, distance traveled by a particle in the rope in a time of 20 seconds. So now the rope, this is where it's going. So the distance traveled in one complete wave is 4 times the amplitude, which is 16 centimeters per wave. 10 per second for 20 seconds is 200 waves in that time. So 200 times 0.16 is 20 times 1.6 is 2 times 16 is 32 meters is E. Okay. 28. Rock falling vertically experiences air resistance force of 12 at an instant when its acceleration is 2. What is the mass of the rock? So 10 m acting down, resistance of 12. So 10 m minus 12 equals ma. So it means that 8m is equal to 12, and m is 12 over 8, which is 3 over 2 is 1.5 kilograms, which is C. Okay. So here, I hope they don't give you graphs like this in the real thing, because it's so difficult on a screen as compared to paper. Radioactive decays in a single step, placed near the radioactive isotope, count rate, it's time, how the count rate changes with time, what's the background rate, what's the half-life. Background rate is clearly 20, which means that 100 of this is due to the actual source, which means that the half-life is where that drops to 50, which means that the true rate is 50, but at the background back in, how long does it take to get to 70? Is that, hold on a minute. So 100 is true. Where do I get to 70? 70 is halfway in between there. So that's exactly 40 seconds. So the half-life is 40. The background is 20. And the answer is A. So for 27 is A. Lock it in. 26. Momentum of a small object moving in a straight line is that, and its kinetic energy is that. So mv equals 24, half mv squared, 96. We want m. Now, importantly, if we square this then, so m squared v squared is 24 squared. So half m squared v squared is 12 times 24. So, and that's 96m. So I really like relating momentum and kinetic energy like that. Now 96 is 8 times 12. So 8m equals 24 and m equals 3, which is A. I'll explain that in more detail. 25. Bleh. Potential difference across the motor and electric car is that, and the current is that. So I can work out the power. Power is I times V. 4 times that, so it's 500 with 3 zeros. Okay. Car accelerates along an horizontal road from rest for 4 seconds. The efficiency of the overall system is 45. So that means the power output of the engine is 0.45 times that many watts. And let's multiply. So the energy, the kinetic energy at the end of that is going to be that times 4, which is going to turn that into 20. So let's say that's 9 over 20. Ah, brilliant. Turns that into 1. So it's 900,000 joules, which is C. Brilliant. I love when this simplifies. Okay, so here. Yeah, heat flow. No one likes this. It's actually not too bad. So I know that the power is Ka times the temperature gradient. So P is proportional to A times, so T1 is bigger, so the temperature gradient is going to be T1 minus T2 all over length of L. A T1 minus T2 over L is going to be C. We'll explain more in the second pass, well, when I'm marking it up. So here, filament lamp. Working at operating voltage converts electrical energy at a rate of 100 watts. The lamp has an efficiency of 5%. How much energy is wasted? 95% is wasted. So 95 watts is wasted. So 95 per second times 60 seconds times 10. Let's think about it the other way. 100 watts times 60 times 10 is 60,000 joules, of which 1/20th, well, 5% of that, well, 10% would be 6,000, so 5% is 3,000. Knock that off here, you're left with 57,000 wasted, which is E. Okay. So here, so many graphs. Okay, 22. Speed time graph for a bus traveling in a straight line between 2 stops. Average speed is total distance over total time. Total distance is the area under the curve. I'm going to get that from the area of the trapezium. So it's going to be the average of the parallel sides. So that there is 20, that there is 80. So that there is 60. So a half of 60 plus 120 is the average of the parallel sides times the distance in between. So that's 12. That is the area, which is the total distance over the total time of 120, is going to give me this answer. It cancels that down for 10. So that makes, put the half in, it's going to make that 30 plus 60, which is 90 over 10, which is 9. which is E. Okay. I am not getting this wrong, not today. 21. When traveling in a vacuum, visible light has a wavelength between that and that. Speed is that. Let's work out frequencies. So V equals F lambda. Frequency equals V over lambda. So 3 times 10 to the 8 over 400 times 10 to the, well, 4 times 10 to the minus 7 would be 0.75 times 10 to the 15, which is 7.5 times 10 to the 14 on that end. And so ultraviolet is on the other side of this 400. So the ultraviolet has a frequency above this. Apologies, just got to charge up my tablet. So what this means is if the frequency is smaller, if the wavelength is smaller than this, then the frequency is bigger than this. The minimum frequency is 7.5 times 10 to the 14, which is G. Okay. Next. So for 20. Okay, resistors are like that. Resistor R3 is now removed and the circuit is reconnected. What is the new current? So the current was that. So V equals IR. 15 makes 30 resistance. I times R. So V equals 0.2 times 30, which is 2 times 3, which is 6 volts. The new current, I equals V over R. So that's 6 volt power supply. If R3 is removed over the new current of 27, which is 2 over 9, which is 0.22, which is B. So for 19, unstable nucleus X becomes stable nucleus Y after a succession of decays, during which a total of 5 alpha and 2 beta are emitted. So 5 alpha and 2 betas. So what's emitted? 10 protons, but you get 2 of them back, so it's 8 fewer protons, which is B. And then I have to go back to 31, which I haven't done yet. I'm actually well ahead of time, which is good. I'll have good checking time, which is good because I want this to be the one. I want this. Okay, no pressure, no pressure. So what is that speed? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get up to there. So that is 500, 480. So it's the point 12, 480. And where else is it a straight line? Yeah, from here. So the other point it goes through is 4 and 80. So in other words, it's traveled 400 meters in 8 seconds for a speed of 50. That's a constant speed. And the weight is 1,000. So it's when the weight equals this drag. So that means that 1,000 is equal to K times the speed of 50 squared, which is K times 2500. Divide both sides by 1,000. So K equals 1 over 2.5, which is 2 over 5, which is 0.4, which is B. I am now done with the questions. Let me check. My answers? Do I have answers for everything? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 answers submitted. Yes, I have answers for everything. Let's go through and let's check some stuff. 36. Epicenter is at the midpoint. No, it can be below. C is equidistant. No. No. None of them are correct. Yeah, I'm good with that. This one, numbers 2, making it 6 volts. 6 volts on that. 8 on that, making that 14. When it's 14, 3, 14 times 3 is 14. Like it. Yep. This one, 18. This is double the current, so 4 times the power. PP, 4P, 6P, 3 watts per. So yeah, I like it. Here, looking at the numbers, I send it as 6, so I need 3 neutrons. 57 gains a proton. D8, I like that. Here, 32. So 72 times that, 90. I'm satisfied with the approach, at least. I don't think I'll be able to do the full check. That I was satisfied with. That I was satisfied with. 0.1 V is 20. So the volume was 200, which means that mass was 200 for the water. So yeah, I like it. So 16 per cycle, that many per second for 20 seconds, 200 cycles. I like it. $10M down, 12 up equals 2A. I like it. The background is 20. Where does it drop to 70? That's in the middle there, which is at 40. So the half-life is, its half-life is 40. So that I like that. Momentum. So 3 times 8, 64, 32. That works. Power is that. That times that gives me 500 with my 3 zeros. 9/20ths times that times 4. 4 times that turns out 20. So then I've got my 9 times 100,000. Yep, I like it. A times T, the temperature gradient where T1 is bigger. I like it. So it would be 60,000, of which 3,000 is useful. So 57,000 is wasted. I like that. Half times the average of the parallel sides, 60 plus 120 times 12 is the distance over the time of 120. Cancel counts as 10. Half, I like that. I like that. I like that. So it releases 10 but gets 2 back. So I like that. And what was the one I didn't check? I've got 30 seconds for. I suppose it doesn't really matter. All right, no, I'll leave it there. So I had time to check, so I did. Apologies if that wasn't very interesting. I'll make a note and timestamp so you can skip if you want to. Okay, let's see how I did. Let's see if this is the one. Not to jinx it. I would never jinx it. Right, 36, A. 35, E. 34, C. 33, H. 32, E. 31, I skipped. 30, C. 29, E. 28, C. 27, A. 26, A. 25, C. 24, C. 23, E. 22, E. 21, G. 20, B. 19, B. 31, B. Boom! Not done that on a live stream before. Full marks. Gah! Feels great. Right? Let me take the time to re-explain anything I need to re-explain that I rushed in too much detail. 36. I think if you just draw it out, it kind of makes itself clear. So if you draw it out, a situation in which this could be true, it's equidistant to x and y. That does not mean it has to be on the midpoint. And it just takes longer to get to z, but you don't know where z is in relation to sort of x and y. So here I can draw it closer to y, but very far away from x. So 2 does not have to be correct, and 3 does not have to be correct, because the distance is 240 kilometers more, but you can see it'll be then much further from x than that. So that's why that's the case. This I'll just do a bit more slowly. So here, I know that when the current in the lamp is 2, the voltage in the lamp is 6. I also know that when the current through the 4 ohm resistor is 2, then the voltage on that is 8. So 6 plus 8 gives me 14 for the overall voltage, which does not change when this resistance goes down to 0, which means that all 14 volts go through the lamp, which means tracking down here, the current in that lamp becomes 3, and 3 times 14 is 42. So that's the method there. The method here. This requires more explanation. What I know is that the current, if that is I, will split evenly because the resistances are the same. And that will recombine to form I again there. I also know that P equals I squared R. Or rather, let me do this from a different orientation, right? Let me instead say that 2I comes out. That's going to split evenly into I and I, which becomes 2I again. And then becomes P equals I squared R. I know this P is going to be I squared R, so I'll call that P. I'll call that P. This one becomes 4I squared times R. So it becomes 4P. So in terms of the total power, it would be 6P. And I know that total power is 18 watts. So a single power is 3 watts, which is the power of X, which is how I got that. That was the fastest route. You could also have done resistances in parallel to therefore get what the yeah, I'll just say that was the most efficient path. And off the top of my head, I'm not finding a quicker one, but like this one I know trips people up. 33, I think I explained okay. It's just remembering that when you release a beta particle, you get a proton back, so that will go up to 58. And the numbers on the top have to add up for the neutrons. This, I think I explained well enough. And then you just sort of solve it. No, I skipped this. But I think I explained that okay as well. So you get the speed from the graph. I'll explain it when I get there. My work. So here, I liked this. So the mass of the cylinder plus the density of water times the volume of water is 290. Do the same for oil. Subtract the two equations. Water minus oil times volume is the 20 grams differential. That difference in density is 0.1, so the volume must have been 200. Therefore, the mass of water must have been 200 grams. So the remaining 90 grams must have been the cylinder. Here, I think I explained that well enough. That's just F equals ma. I think that was fine. This, I think, was good. Just a lot of people forget to put the count rate back in. So a lot of people go, oh, 120, and it takes 50 seconds to get to 60. So they think that the half-life is 50 seconds when it is not. Because a further 50 seconds after this, you do not get to 30. The true count rate at the start is 100. So the true count rate at the half-life is 50. And if you add the background of 20 back into that, that's really 70, which is why the half-life is only 40. Very common mistake. But the background, very obviously 20 just from the graph. 26, I love this. I really highly recommend you learn how to do this, especially for sort of interview and to make your life easier in these. So from this, you can see that momentum squared is m squared v squared. So a half times momentum squared is a half m squared v squared. So momentum squared over 2m is equal to the kinetic energy. And so that's kind of the idea that I used. So momentum squared over 2e is equal to m. Now, keen physicists will recognize this as being sort of used in E equals mc squared type of stuff. So that's basically what I did. I said it was 24 squared over 2, which is 12 times 24 instead of 24 times 24, divided by the kinetic energy of 96. And I got m equals 3. Much, much easier than trying to actually solve the simultaneous equations. Just substitute one into the other, which is basically eliminating for v, because we want to find m. So you could also, I suppose, have done that by saying v is equal to 24 over m, substituting into there, and you get functionally the same thing. Here, I think I explained that okay. Here, people hate this because it's not explicitly done in the syllabus. But the idea is the rate of energy transfer is equal to the thermal conductivity times the cross-sectional area times the temperature gradient. So the temperature gradient here will be the change in temperature, which is T1 minus T2, all over the distance, which is L. And the constant of proportionality is this thermal conductivity constant. By the way, while we're here, because it's a uniform metal bar, we know that the predominant factor in the thermal conduction are the conduction electrons. So actually, the factors affecting the rate of power transfer are remarkably similar to the factors affecting the resistance. So we know resistance is rho L over A. And I know that when resistance goes up, the power goes down. So the bigger the resistance, the smaller P is. So I know that P is inversely proportional to resistance because the power is kind of like the current. So the faster the conducted electrons move through the substance, the faster the energy gets transferred. And that's current. And we know V equals IR. So I is inversely proportional to R, which means that P is inversely proportional to R. So P is proportional to A over L. And that's how you can get this part. And then the rest of it is due to the bigger the temperature difference, the faster the power travels as well. So there's lots of different ways you can think about this and make good connections. 23. I liked the way I did that by flipping it around and thinking about actually the useful power would be easier to get rid of rather than finding 95% of something. This I'm happy with. This I'm happy with. This I'm happy with. This I'm happy with. And do I need to go into 31? Not really, only to say that at that point, we know it's reached terminal velocity, which means the weight of 1,000 down has equaled the weight of the 2,500k acting up. Constant speed means no resultant force because it is not accelerating. So that's why I equated them and then solved for k. Right. I'm pleased with that run. That was a good run. It'll be interesting, I think, for you to compare this with my other runs to see if something seems different in my presentation. I certainly felt more locked in and confident. And I felt like the work I was doing was actually definitely going to get me the marks, which was good. Obviously, in the real thing, you're not going to get marked in between each of the sections, so you don't get to know how well you did and kind of carry that confidence through. So here I was like, "Ooh, this is a good run." You won't really know that in the real thing. But I think especially in the Math 2 run, once I spotted a trick, I committed to it and really like leaned in, almost like when you find a downhill section on a run and you just power forward. So that was good. I would say I think that paper felt easier than actual ESAT papers, and I think you'll feel this yourself. Sort of, they get harder as the years progress. Everyone always finds the actual ESAT that they sit to be the absolute hardest one that they've ever seen, mainly because the pressure is really on then. But it is still worthwhile taking these easier papers to practice your technique. So some of the things I did well, if I got a question wrong, I just moved on without thinking about it, without stressing. If I thought a question was doable but would take time, I just skipped it, and I did that really well in Math 2. So Math 2 was my perfect run, where every single question that I did in the first pass was correct and under 90 seconds, and every question I did in the second pass was much longer. So that's kind of what you want. In this physics pass, there were a few questions I took a little bit too much time on, but then that was counterbalanced by the questions I was doing really, really quickly. And so overall, I ended up giving myself a whole 5 minutes to check on my answers, which was good for confidence. If you do have the time to check, I would encourage it. You'll see that I didn't necessarily fully recalculate everything, but it just sort of gave a scan and went, is this method a good method? Yes, it is. I'm kind of happy with that. I can kind of leave that. I feel okay about it. You'll notice that the reason why I was able to do so well in that and spot all the little tricks is because I've really mastered the syllabus. So looking at that binomial expansion and instantly spotting the difference of two squares there. Or with the integration, knowing the trick that was going to make that happen a lot faster. So good syllabus mastery is really the name of the game here. Everything that is in the ESAT specification, make sure you are absolutely secure on, including things that aren't necessarily in your syllabus, like the rate of thermal energy transfer that we just saw in that physics. So I'm happy to leave it there. Hopefully you get some good insight into how I use my techniques to get the most out of myself, but think not just about like the technical stuff I was doing, really think about the psychology I was bringing to it. How was I getting that confidence, building that momentum, and making sure I was putting myself in a good state of mind to get my best workout instead of feeling defensive and on the back foot. Making sure that the first question you do is actually a really good question that it sets the tone of the paper and that you feel like, yeah, okay, I've got this. I've got this. You want that kind of like attacking, fighting feeling. And I really kind of hit that today. So that psychology, watching me go through the full process, is hopefully something you could take on. So some of the things you might take on, let's say you're in your run, managing your mindset is as important as managing the questions. So let's say you've got a string of questions which aren't feeling too good. Just skip them. Like, nope, got to protect the brain. Skip. You can always flag and come back to them, but find the next good question, build that back up. Okay, still got this, still in the game. So keeping yourself in that right mental zone is actually really important for getting your best workout. And that's something you can practice in your full runs. So hopefully it's given you something to think about. I'll leave that with you. I think that's a good time to stop. I will be back for my live solve next week, going through the TMUA, just making sure I get through all the TMUAs and the NSAs slash ESATs ahead of the January cycle. I'll also continue doing my interview series for at least the next couple of weeks before the interviews happen. So yeah, we got good stuff coming up. Hopefully you find it useful. And in the meantime, take care. Work hard. Have a bit of fun. It is fun. All right, guys. I'll see you next time.